Children, let us continue the chapter Quadrilateral. Now let us solve the exercise 2, which is based on the midpoint theorem and also on the properties of quadrilateral. Now the first question is, ABCD is a quadrilateral in which P, Q, R and S are midpoints of the sides AB, BC, CD and DA. AC is a diagonal. Show that SR is parallel to AC and SR equals half of AC. Second one, PQ equals SR. Third one, PQRS is a parallelogram. Here we have to consider the triangle ADC, and as S and R are the midpoints, SR is the line joining the midpoints of two sides of the triangle ADC. So it must be parallel to AC and half of AC. So you can write SR equals half AC. So you write here solution given. What is given here? ABCD is a quadrilateral. P, Q, R and S are midpoints of AB, BC, CD and DA, and AC is a diagonal. So you write ABCD is a quadrilateral. ABCD is a quadrilateral. P, Q, R, S are the midpoints of AB, BC, CD, DA respectively. Now let us consider the triangle ADC. In triangle ADC, so you write SR is a line joining the midpoints of AD and DC respectively. AD and DC respectively. Therefore you can write here what you can write. Therefore you can write that SR is parallel to the third side AC, and also SR is half of the third side AC. SR equals half AC. That the reason is here according to midpoint theorem. The reason is midpoint theorem. Here the first question is to show that SR is parallel to AC and SR equals half AC. So you got that one. That is the first one you got. Next you come to the second one. To prove that, the second one, PQ equals SR. Here to show that PQ equals SR, you know that here you proved SR equals half AC. Similarly, by taking the triangle ABC, you can prove that AC is also, this PQ is also half of AC. That is according to the midpoint theorem. In triangle ABC, you can say that PQ is also half of AC. So SR is half of AC and also PQ is half of AC. Therefore, you can write that SR equals PQ. Now you write in triangle ABC. In triangle ABC, here P and Q are the midpoints, or you write PQ is a line joining the midpoints of AB and BC respectively. AB and BC respectively. Therefore, you can say that PQ is parallel to AC and also PQ equals half AC. PQ equals half AC. The same reason, that is the midpoint theorem. Midpoint theorem. Now here, in the first you proved that SR is half of AC, and in the second you proved that PQ equals half of AC. So here, to prove that PQ equals SR, you can take that first and second. Therefore, here you take from first and second, you can write that PQ equals SR. PQ equals SR. You know that things which are equals to the same thing are equal to one another. That is, PQ equals half AC and SR is also equals half AC. Therefore, PQ equals SR. Next one, what you have to prove? Prove that PQRS is a parallelogram. Here you take the quadrilateral PQRS. To prove PQRS is a parallelogram, take the first and second here. In first, what you proved? In first, we proved that SR is half of AC and SR parallel to AC. In second, we proved that PQ is half of AC and also PQ parallel to AC. So you write in the quadrilateral, PQRS, first one you write SR equals half AC, or you write first SR parallel to AC and SR equals half AC. SR equals half AC, that is proved in first. We proved in first, and also we proved that PQ is parallel to AC. Also we proved PQ parallel to AC and PQ equals half AC. PQ equals half AC. Here we proved this second. We proved in second. Now here you consider this is the third and this is the fourth. Here the same line AC is parallel to PQ and also parallel to AC, or the two lines SR and PQ are parallel to the same line AC. Therefore, you can say that SR parallel to AC. So, you take from third and fourth. From third and fourth, what you can write? SR parallel to PQ and also SR equals PQ. SR equals PQ. Therefore, you write PQRS is a parallelogram. PQRS is a parallelogram. The reason opposite sides are equal and parallel. If opposite sides are equal and parallel, then you can say that it is a parallelogram. A pair of opposite sides are equal and parallel. Pair of opposite sides of a quadrilateral are equal and parallel. Equal and parallel. So here we proved that PQRS is a parallelogram because PQ parallel to SR and also PQ equals SR. We know that in a quadrilateral, if a pair of opposite sides are equal and parallel, then it is a parallelogram. Now the second question, ABCD is a rhombus and PQRS are the midpoints of the sides AB, BC, CD, DA respectively. Show that the quadrilateral PQRS is a rectangle. Here it is given that ABCD is a rhombus, P is a midpoint of AB, Q is a midpoint of BC, R is a midpoint of DC, S is a midpoint of AD, and we have to prove that PQRS is a rectangle. PQRS is a rectangle, and you know the properties of rectangle. PQRS is a rectangle means we have to show that PQRS is a parallelogram with angle, each angle 90 degree. Here we have to show that angles of the quadrilateral PQRS is 90 degree. Take the solution. Here given, what is given? ABCD is a rhombus. Given ABCD is a rhombus. P, Q, R and S are midpoints of AB, BC, CD and DA. PQ, RS are midpoints of AB, BC, CD and DA. Now you take triangle ADC and here SR is a line joining the midpoints of AD and DC, and according to midpoint theorem you can say that SR is parallel to AC. SR is parallel to AC and SR is also half of AC. So you take in triangle ADC, SR is a line joining the midpoints of AD and DC. Therefore you write SR is parallel to AC and SR equals half AC. SR equals half AC. So here again you take in triangle ABC. Here the reason is midpoint theorem. And you write this is first. Then you write in triangle ABC. In triangle ABC, PQ is a line joining the midpoints of AB and BC respectively. So here you can write that PQ is parallel to AC and PQ is half of AC. The same reason you can give, that is the midpoint theorem. theorem. So consider this is second. Here you consider this is the first, this is the first and this is the second. So from first and second you can write that, therefore from first and second. Here SR is parallel to AC and SR is also half of AC. Similarly, PQ is parallel to AC, PP is also half of AC. Therefore, the same line is parallel to two different lines, or two different lines are parallel to same line. Here SR and PQ are parallel to the same line AC. Therefore, you can say that SR is parallel to PQ. PQ is parallel to SR. Therefore, here PQRS is a parallelogram. You got that PQRS is a parallelogram. Now, let us write that one. Therefore, you can say that PQRS is a parallelogram. PQRS is a parallelogram. Reason: in a quadrilateral, if a pair of opposite sides are equal and parallel, then it is a parallelogram. That is the reason you know here. So you got that PQRS is a parallelogram. Now we have to prove that any one of the angle is 90 degree. Now here you know that the diagonals of a rhombus bisect at right angle. Therefore, angle, if you take, this is the O is the point of intersection of the diagonal AC and BD, and at a point O the angles are 90 degree angles. So if you consider angle DOC is 90 degree angle. Now you take E, which is a point on RQ, and F, which is a point on SR. And you know that here SR is parallel to AC, therefore FR must be parallel to OE. As SR parallel to AC, FR must be parallel to OE. And also here RQ is parallel to DB according to midpoint theorem. R and Q are the midpoints of CD and BC. Therefore, according to midpoint theorem, RQ is parallel to DP. Therefore, RE must be parallel to FO or OF. So, again you will get a parallelogram OERF in which the angle EOF is a right angle, and you know that the opposite angles are equal. Therefore, the angle R SRQ is also equals to 90 degree. As SRQ is the angle of the parallelogram PQRS becomes the rectangle. So you take, let SR and DB. So here to prove, you take to prove that an angle of parallelogram PQRS is right angle. PQRS is 90 degree. Here why you have to prove 90 degree? You know that in a parallelogram, if a angle is 90 degree, then it is a rectangle. To show that it is a rectangle, there is a need of 90 degree angle. So to prove this, here let us take the point E and F. Let E is a point of intersection of AC and RQ, and F is a point of intersection of F is a point of intersection of DB and SR. DB and SR. Here F is a point of intersection of DB and SR. E is a point of intersection of AC and RQ. Now you take here, it is also given that here SR is parallel to AC, means here you take O is the intersection of the diagonal AC and BD, and O is the point of intersection of diagonals. Point of intersection of diagonals. Now here you take in quadrilateral OERF, you take here OF parallel to RE as DB parallel to RQ. Right? OF parallel to RE and FR parallel to OE. So here why it is, we know that according to midpoint theorem, SR is parallel to AC and also RQ is parallel to DB. That is according to midpoint theorem, as the SR is parallel to AC, AB, FR is parallel to OE, and also as RQ is parallel to DB, OF is parallel to RE. So you write, this is first here you write RQ parallel to DB, because first OF parallel to DB is there. So you write RQ, here you have taken that OF parallel to RE, therefore you write first the reason is RQ parallel to DB and SR parallel to AC. So as RQ parallel to DB, OF is also parallel to RE, as here you know that OF is a part of SR, OF is a part of DB, and RE is a part of RQ, and FR is a part of SR. Here OF is a part of OF is a part of DB. And SR is a part of SR is a, here RE is a part of R cube and FR is a part of SR. See here, SR is a part of FR and OE is a part of AC. OE is a part of AC. So here you got that. Therefore, OERF is a parallelogram. OERF is a parallelogram. Reason, a pair of opposite sides are parallel. Opposite sides are parallel. Now, you know that, and also we know that in parallelogram opposite angles are equal, and here angle FOE, first you write angle FOE equals angle FRE. First you write here angle FOE equals 90 degree. Why angle FOE equals 90 degree? Diagonals AC and DB of a rhombus bisect at right angles. Bisect at right angles. And you also know that angle FOE equals angle FRE. That is also 90 degree. You know that opposite angles of a parallelogram are equal. Opposite angles of a parallelogram are equal. Now you can say that therefore PQRS is a rectangle. As we got that PQRS is a parallelogram with a angle 90 degree. Here you got the angle R is 90 degree. So you got that PQRS is a rectangle. That is, you write that is angle R equals 90 degree. The third question, ABCD is a rectangle and P, Q, R and S are midpoints of the sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is a rhombus. Here what is given? You need note down the given. ABCD is a rectangle. You know the properties of rectangle. What are the properties of rectangle? In rectangle, opposite sides are equal and diagonals are also equal, and each angle is equals to 90 degree. First you write the opposite sides are equal. That is the main property of the parallelogram also. And the main other special property is diagonals are equal. You write AC equals BD. Here only one trigonal is drawn, but you know that DB is also diagonal. AC equals BD. And PQRS, PQR and S are the midpoints of AB, BC, CD and DA. AB, BC, CD and DA respectively. And what you have to prove here? We have to prove that PQRS is a rhombus. You know that rhombus is a quadrilateral in which all the four sides are equal. That you have to show here. Here what you have to show? We have to show that all the four sides are equal. Now, here you know that if you take the triangle ADC, in triangle ADC, SR is half of AC and SR is parallel to AC. Similarly, if you take the triangle ABC, PQ is parallel to AC, PQ equals half of AC. Then you will get PQ equals SR and PQ parallel to SR. And also it is a parallelogram. And you know that if you draw the diagonal DB, then you will get the triangle BCD, and RQ is the midpoint of the lines CD and BC. So RQ is half of DB and RQ is also parallel to DB if you join these diagonals. And also SR is half of DB and SR is parallel to DB. Then you will get SP is also equals to RQ and SP is also parallel to RQ. In this way you will get PQRS is a parallelogram. And next we have to prove that the adjacent sides are also equal. SP equals PQ and SR equals RQ. Now you take here all angles you take, and also angle A equals angle B equals angle C equals angle D equals 90 degree. Then in triangle ADC, so you know that SR is parallel to AC and SR equals half AC. The reason is, here you take, that is the first one. What is the reason here? Midpoint theorem. Midpoint theorem. According to the midpoint theorem, you got it. Similarly, you take the triangle ABC. In triangle ABC, you write PQ equals half AC and PQ parallel to AC. Consider this is the second, the same reason. What is that reason? Midpoint theorem. Midpoint theorem. Now from first and second you can say that from first and second you got that PQ equals SR and PQ parallel to SR. So you write PQ equals SR and PQ parallel to SR, and you got that PQRS is a parallelogram. PQRS is a, therefore you got that PQRS is a parallelogram. PQRS is a parallelogram, and you have to show that all the four sides are equal. If you prove that adjacent sides are equal, then naturally all the four sides becomes equal. Now let us take the triangle SAP and triangle BQP and prove that they are congruent. How will you prove that they are congruent? As P is a midpoint of AB, you can have AP equals BP, and also here S and Q are the midpoints of AD and BC. So they are AS and BQ are the halves of the equals. So here AS equals BQ. And you can have that the angle A equals angle B. Angle A means angle SAP equals angle BPQ. Both are equals to 90 degree. Then you can have the triangle SAP is congruent to triangle PBQ according to SAS congruence rule. So write the names of the triangle. In triangle SAP and triangle QBP. So you write AP equals PB. P is a midpoint of, that is given here. P is a midpoint of AB. You can also write given here. And also AS equals PQ. AS equals PQ, that is both of them, they are half of AS and BQ are halves of equals, halves of, you write halves of AD equals BC. AD equals BC. Here you know that AD equals BC, they are the opposite sides of the parallelogram or rectangle. As S and Q are the midpoints, here AS is half of AD and BQ is half of BC. And as AD equals BC, half of equals are also equal. And you write angle SAP. Angle SAP equals angle QBP. Both are equals to 90 degree. That is also given. Then you can write that therefore triangle SAP is congruent to triangle PBQ according to SAS congruence rule. According to SAS congruence rule, right? SAS congruence rule. Therefore, you can write that SP equals PQ. SP equals PQ according to CPCT. According to CPCT. Here you got that PQ equals, here PQ equals SR. You got PQ equals SR, and also SP equals RC. SP equals RC because here if you prove the triangle, if you take the triangle ADB, SP becomes the line joining the midpoints of the two sides of the triangle. So SP is half of DB and also RQ is half of DB, and then you will get SP equals RQ. SP equals RQ and SP is also equals to PQ. So you can have that the adjacent sides are also equal. Here as PQRS is a parallelogram. That you have proved here. As PQRS is a parallelogram, we got that SP equals RQ and also and SR equals PQ, and we got SP equals PQ. So therefore you can say that here PQ equals RQ equals SR equals SP. So here you write this is the third one. This is the fourth one. So you give the reason third and fourth. In a parallelogram, you know that opposite sides are equal and parallel. If you prove the adjacent sides are equal, then it becomes the rhombus. Here SP equals PQ means here PQ is equals to this SR and also SP equals to RQ. All the four sides becomes equals. Therefore it is a rhombus.